Have you ever wondered just how clean your kitchen counter is? You eat from it, you make food on it, you probably make contact with the counter many times without even realizing it. To test how clean your kitchen counter is and to know what's the best way of cleaning it, we have a cool experiment for you to try. Our experiment started from the big question: out of alcohol, vinegar, and water, which is the best cleaner? From this, we decided to test it on our kitchen counter, which we thought would be quite dirty from our day-to-day use. Our kitchen counter contains lots of tiny germs, which over time can develop into mold on bread. To measure this, we used bread to wipe the kitchen counter that has been cleaned with different cleaners. This allows the bread to be the house where the mold lives and grows. If the cleaner isn't very good, then our counter will be more dirty and we should see more mold growing on our bread. But if our cleaner works, well, then we should see less mold growing on our bread. So what do we need? We need 3 slices of bread, 12 small Ziploc bags, paper towels, a clean knife, water, vinegar, 70% or above alcohol, and masking tape. For our experiment, we used the no-name brand white vinegar, Life brand 70% isopropyl alcohol, and milk bread from TNT. So let's get started. The first step is to clear a space on the kitchen counter, roughly a 30cm by 30cm square. The second step is to use masking tape to divide the square into 3 equally sized spaces. In the third step, use a paper towel soaked in water to clean the first space, a paper towel soaked in vinegar to clean the second space, and a paper towel soaked in alcohol to clean the third space. Let the areas dry briefly and label the spaces with the cleaner you wipe them with. For the fourth step, using clean hands, knife, and cutting surface, take out 3 slices of bread and cut each slice into 4 equally sized squares. You should have a total of 12 squares of bread as a result. Now the fifth step. Take 1 square of bread, wipe over a section of one of the clean spaces, then immediately put it into a sandwich bag and close it. Label the bread with masking tape, including the date, the cleaner, and the trial number. Repeat step 5 3 times for each space so that you will have 3 baggies from each space. Trials 1, 2, and 3. But you may be wondering, why do we need to repeat each cleaner with 3 slices of bread? We want to make sure the result we're getting from each space is similar for all 3 slices and that our result wasn't by chance. The more trials we have, the more true our results will be. Sixth step. Put the remaining 3 squares of bread into sandwich bags without contact with the counter and label them as controls. The control group is one that hasn't undergone any changes, and we use this as a standard to compare our experimental breads with. The last step is to set the bags aside in a cool place and watch for the mold growth and record the data over the next few weeks. We recorded data for our bread slices every 3 to 4 days for 30 days. Once we started seeing mold, we recorded our data by percent coverage. The next important step to our experiment is making sure that our data is reliable enough to make a conclusion. The ANOVA is a statistical test which checks if the averages of 2 or more groups are significantly different. Even though the percent coverage numbers may say that alcohol is the best cleaner, because it has the lowest percent coverage, we need to check if our numbers are truly different enough from each other, which is why we use ANOVA to test it. To start, we make a prediction about our results for the ANOVA test. Let's say our prediction is that the percent coverage averages for the 4 different bread cleaners won't be significantly different, and we can't draw a conclusion from those results. But our alternative prediction is that the percent coverage averages for the 4 different bread cleaners are significantly different, and we can draw a conclusion from the results. For an ANOVA test, we need 2 special numbers, a p-value and an alpha. Those 2 numbers allow us to find out whether we can accept or reject the original prediction we make. When the p-value is less than the alpha value, we reject the original prediction and accept the alternative one. Our p-value, which was 0.01855, was less than the alpha, which was 0.05, so we accept the alternative prediction. Performing the ANOVA test allowed us to find that the percent coverage averages of the 4 different bread cleaners are statistically significantly different. What does this all mean? With the ANOVA test, we proved that our data was statistically significant enough to draw conclusions. Going back to our original question in the beginning that started this experiment, we can conclude that alcohol is the best cleaner out of water, vinegar, and alcohol. We observed the least amount of percent coverage of mold for bread swiped with alcohol. Therefore, alcohol was the best cleaner. The best way to make this experiment foolproof is repetition and variation. Make sure you try this experiment yourselves and see if you get the same results as us, and try looking at the data over varying time periods. We looked for the best cleaner based on the data for 30 days after preparing the bread slices, but you can try it for data for 20 days, 40 days, and see how that changes the results. So stop loafing around and get ready for some experiments. Thank you for listening.